In this experiment, we will deal with whole milk, food coloring, and hand soap. And whatever we will do with the milk, we will do it with the water to compare. So this is my bowl of water here, and that's whole milk on that side. So first we will pour some drops of food coloring in both dishes, and let's try to make like 4 spots. And now in the milk. So food coloring is water soluble, so it will dissolve well in any aqueous solution. And so in the milk, it only dissolves in the aqueous part of the milk. So now we will use a wet Q-tip. So I will wet my 2 hands of the Q-tip, and we will dip the Q-tip, the wet Q-tip, in the center of each dish. So first with water. We didn't see much happening there. Now let's dip the wet Q-tip in the milk. We saw the food coloring being pushed a little bit on one side only. And the second test we will do is dip a Q-tip that is full of soap, hand soap. So I will coat the end of the Q-tips so that they're coated with soap. Then the other end of the Q-tip. And again, I will dip the Q-tip in the center of the dish, first starting with water. We don't see much change in there. And now let's dip the Q-tip with soap in the milk. And we saw how the food coloring was repelled in the milk. So again, food coloring is water soluble, so it dissolved in the water part of the milk. And the soap molecule is mainly a long chain of carbons and hydrogen, which is a nonpolar. And that long chain of nonpolar molecules, they will interact with the fat of the milk, because milk is made of water and fat, among other things. And so the fat of the milk will interact with the long tail, nonpolar long tail of the soap. And at the same time, the long nonpolar tails of the soap will repel the aqueous part of the milk.